Hello, dear students. I hope all of you are well prepared with 1.1. Okay, what we studied in 1.1, we studied four properties of areas of triangles. Using those properties, today we are going to prove first theorem of this chapter, similarity. That theorem we call basic proportionality theorem, which is there for 3 or 4 marks in your board exams. Fine. Let's see the statement of this theorem. If a line parallel to a side of a triangle intersects other sides into distinct points, then the other sides are divided in the same ratio by 8. Now, the very first and very important step towards proof is to draw proper figure. The part of statement following if, we call this as antecedent, okay, which is written in green color. Okay, I'm highlighting that part. So let's read that much only. A line parallel to a side of a triangle. So let's draw triangle first. Let's name this triangle, say triangle ABC. Okay. A line parallel to a side of a triangle. So let's draw a line parallel to a side of a triangle. You can draw parallel to AB, parallel to AC, parallel to BC. But generally we draw parallel to the side which is parallel to the ground level. So let's draw parallel to BC. It intersects other sides in two distinct points. So the position of this line must be like this, intersecting side AB and side AC in two distinct points. Let's name those points D and E. Okay. Now, so first step is done, figure is drawn. Now, whatever there in that figure, we are going to write this as given. So let's start writing given. Two steps, two statement given. In triangle ABC, line DE is parallel to side BC. At the same time, we have to mention points of intersections. Okay, so let's write line DE intersects side AB and side AC in points D and E respectively. Next step, what is to be proved? The latter part of statement following then. Okay, part of statement written in red color. I'm highlighting this part again. Let's read that part. The other sides are divided in the same ratio by 8. Which are the other two sides? AB and AC. Look at AB first. Because of line DE, AB is divided into two parts, AD and DB. So let's form the ratio, AD upon DB. Second side now, AC. Look at AC. AC is divided into which two parts? AE and EC. Let's form the ratio of corresponding side. Here, corresponding word is very important because corresponding part of AD is AE and corresponding part of DB is EC. So let's form the ratio AE upon AC. Let's read again. The other sides are divided in the same ratio by 8. Same ratio. That means we have to show those ratios are equal. Fine. Now, this is a three-step process. 1. Look at TP to prove. 1. Try to get left-hand side first. Then try to get right-hand side of to prove. And then try to equate them. Okay, I'm repeating again. First step, try to get LHS. Second step, try to get RHS. Third step, try to equate them. So let's start with LHS. Look at LHS. What we have? AD upon DB. When I started the lecture, I said using properties of areas of triangles. So let's recall all four properties. 1. When bases and heights both are different, we get A1 upon A2 is equal to B1 into H1 upon B2 into H2. When bases are equal, we get A1 upon A2 is equal to H1 upon H2. When heights are equal, we get A1 upon A2 is equal to B1 upon B2. And obviously, fourth one, when bases and heights both are equal, we get A1 is equal to A2. Now, we are going to decide exactly which property is applicable here. Okay, see how I'm thinking on it. Look at left-hand side again. Left-hand side, we need ratio of single segments. Single segments. But if you look at right-hand side of first property, we have the ratio of product of two segments. But here we need ratio of single segment. That is why first property is not applicable. Okay. Even fourth property, we have areas equal. And when you go for ratio, we get 1:1. So this property is also not applicable. Now, second and third property. Now we are going to decide which property is applicable. Look at AD and DB. I'm drawing AD and DB separately. Look at AD, DB. Okay. There is no perpendicular sign. That means AD and DB cannot be the heights. That means AD and DB cannot be H1 and H2. Okay. So this property is not applicable. So we came to conclusion that AD and DB must be the bases. Okay. That means we have to obtain two triangles having bases AD and DB. Fine. Now we have seen so many situations, or we can say the figures where we get the heights equal. Okay. But if you look at AD and DB, they are lying on the same line. So recall the figure where we get the bases on the same line. This is the situation we have. Right now there are three triangles, but I'm considering only two triangles, triangle PQS and triangle PSR. To avoid the confusion, I'm considering two triangles only, triangle PQS and triangle PSR. Base of first triangle, triangle PQS, base is QS, base of triangle PSR is SR. Fine. Now, if I draw height from point P, you will find that PT is the common height for both the triangles. So here you will find those two triangles. They have their bases lying on the same line and they have common vertex here. So whenever such situation, we know that the triangles have same height. Triangles have same height. Fine. Now, to get the clear idea, what I'm doing here, look at AD and DB. Here we have those bases, they are in vertical position. So to get the clear idea, I'm rotating this figure in this position. Look at QS and SR. They are lying on the same line and common vertex is P. AD, DB lying on the same line. So there must be common vertex. So I'm taking E is a common vertex. Okay. Now we are going to create two triangles having bases AD and DB. First triangle is already there, triangle ADE. Second triangle having base DB. So to get that triangle, we'll have to draw BE. Okay. So second triangle we got, triangle BDE. So I got first construction, draw segment BE. You must know why you are doing that construction. Okay. So let's write construction, draw segment BE. Now we'll apply this property A1 upon A2 is equal to B1 upon B2. So let's start writing proof now. First statement, A1 upon A2, that is area of first triangle upon area of second triangle. Area of triangle AD upon area of triangle BDE is equal to B1 upon B2, their corresponding bases. AD upon DB. AD is the base of first triangle, DB is the base of second triangle. Reason is very important. Areas of triangles proportionate to bases. Now this reason is as per your textbook, but if some students, they are finding this difficult to remember, they can simply write triangles having same height. Okay, next one. Now we'll move to RHS. Look at RHS. Now I want to get AE upon EC. AE upon EC. So let's draw AE. Let's draw EC. Can I say the same situation? Bases lying on the same line. This figure will help you to get the idea. QS, SR, lying on the same line, common vertex, P. So here I am taking common vertex D. Okay. Let's try to get first triangle having base A. Look at A. So A and E will have to join A with D and D with E. So already there, those segments are there. So first triangle is already there. Now triangle having base EC. To get that triangle, we'll have to join C with D. So second part of construction, draw segment CD. So let's add here and segment CD. Let's apply the property now. Again, A1 upon A2 is equal to B1 upon B2. Area of first triangle. Keep the same naming like first statement. Area of triangle ADE upon area of triangle CDE is equal to B1 upon B2. That is AE upon EC. Reason will remain same. Areas of triangles proportionate to bases. Okay. So now I got LHS. I got RHS. So two steps we have done. Now my job is to equate them. So now I want to show RHS equal. When we can say RHS of two statements, or you can say two equations, they are equal when their left hand sides are equal. So now my job is to get left hand sides equal. Now if you look at left hand side, we have two ratios. When we can say two ratios equal, when their numerators are equal and denominators are equal. Let's check. Look at numerator, area of triangle ADE. Numerator of first ratio, area of triangle ADE. Numerator of second ratio, area of triangle ADE. Are they equal? Yes. So half of the part is already there. Numerators are already equal. Look at denominator now. Area of triangle BDE, area of triangle CDE. If I get areas of those two triangles equal, I can say denominators are equal. Okay. Now, I'm separating those two triangles from original figure. Triangle BDE, next triangle CDE, correct? Now my job is to get their areas equal. When we get areas equal, fourth property, A1 upon A1 is equal to A2. Sorry, A1 is equal to A2, correct? Now, again, we have several situations where we get areas equal, okay? Recall this situation. Consider triangle PQR, triangle SQR, common base QR, and they lie between same two parallels, L and M. If I draw height from P and S, you get their heights are equal. PT and SN heights are equal because the perpendicular distance between same two parallel lines equal. Okay, so in this situation, you will find those two triangles have same base and same height. So in that case, their areas are equal. Let's check for this figure. Do we have the same situation here? Okay, look at those two triangles. Now I cannot take BC as a base. Okay, because some students, they have query about why can't we take BC as a base. BC is not the side of any triangle here. Here the base is what? D. So D is a common base. So let's write triangle BDE and triangle CDE have common base DE. Okay, next step. Now we'll check whether they lie between same two parallel lines. Do we have anywhere parallel? Yes, look at given line DE is parallel to BC. So let's write this. Line DE is parallel to side BC. Okay. When two triangles lie between same two parallel lines, their heights are equal. So let's mention this. Triangle BDE and triangle CDE have equal heights. So we got common base and equal heights. What is the conclusion? I can say those two triangles have same area. So area of triangle BDE is equal to area of triangle CDE. Reason, triangles with same base and same height. Fine. So this way we got denominators equal. So numerators equal, denominators equal. I can conclude ratios are equal, ratios equal. That means I got left hand side equal. Look at this. If left hand side, reason here, reason is very important from 1, 2, and 4. Okay. So if left hand sides of two statements are equal, what is the conclusion? Right hand sides are equal. So what we get? AD upon DB is equal to AE upon AC. Reasons from 1, 2, and 5. Fine. So this way we got this result. Other two sides are divided in the same ratio. Okay, now I am removing all other figures which are drawn for explanation purpose. So this is a proof we have, BPT. Okay. Now on second slide, I will show you presentation of this. First step, draw proper figure. Second step, given. Third step, to prove. Fourth step, construction. Fifth step, of proof, statement, and proper reason. Okay. And after completion of this proof, do not forget to add the statement like this. Hence, it is proved if a line parallel to a side of a triangle intersects other sides in two distinct points, then the other sides are divided in the same ratio by it. Okay, so this is a presentation we have. Now I want to add something here. Look at first and second reason. If some students they are finding it difficult to remember, they can simply write, as I said earlier, simply you can write triangles having same heights. But if some students they are expecting out and out marks, okay, and if they have the enough time, if you have the enough time, you can write the full statement here. The ratio of areas of two triangles having same height is equal to the ratio of their corresponding bases. Okay, so that way you can present this theorem. I hope now it is very clear, this proof of BPT. Okay, thanks for watching this video. All the best.